Hey everyone, today I have a video on observer-based logic. So this is a type of logic that uses only observers, rails, and pistons to be completely one-wide tillable essentially. Now I've used this in quite a few contraptions so far, but each time I needed to use some kind of logic gates, I always had to make my own because whenever I would look around on YouTube or some other places for resources on that type of logic, I would never really find them. The only one I found was this Xor Gate over here that someone posted on Discord at some point. So I thought I would make a video on this type of logic just so people can use it as future reference. Um, so let's start with the transmission line. Now this is the simplest example. The way this works is basically just like a redstone transmission line, but obviously it's one wide tillable. Now the way this works is you have a pulse that you decompose, a signal that you decompose into a pulse using an observer, and then you reconstruct the signal using a T flip-flop at the other end. Now this has the advantage that it makes a bunch of logic really simple. So for instance, a NOT gate is literally the exact same thing as a transmission line, except that you invert the T flip-flop at the end. Now, another really cool thing about this type of logic is that it simplifies XOR gates. So usually an XOR gate using redstone is quite complicated to do. You need both an OR gate and an AND gate. But using this type of logic, it's literally just two observers feeding into a rail. So we can test it. And there we go. Standard XOR gate. It behaves kind of like an OR gate does in redstone. It's literally just two lines that merge into one. But obviously, like, it's not just advantages using this type of concept. The problem is AND gates and OR gates are pretty non-trivial to make. So for an AND gate, what you do is you have to do a bit of the same thing that we do in normal redstone. So we have this rail over here, and we need to retract both blocks to turn it off. So if I do just one, it does nothing, and then both, then it lights up, just like an AND gate. Now the OR gate, we're all used to OR gates being just a single redstone wire, but using edge-triggered logic, it's actually not that simple. It's essentially the same thing as an AND gate, except these two flip-flops over here are inverted. So basically, there we go, OR gate. Now this is just the basic logic gates, but you can actually create some pretty cool and compact stuff using these logic gates. So I've already shown a video of a decoder and an encoder using that type of logic. So I won't go over exactly how these works, but this is just a binary decoder. So for instance, if I do 3 in binary, then the fourth one lights up because we start counting at 0, obviously. Who doesn't start counting at 0? This one is a bit different from the one I showed in my video because it updates automatically. You don't have to press a button, but it works based on the same principle. This here is the encoder. It's literally copied from my other video. So for instance, if I light up 3, then we get 3 in binary. It's just the reverse of this one. Now I've also done some other stuff. So for instance, this here is a binary counter. That's one wide tillable. It works on the same principle of standard binary counters. So whenever you give it an input, it counts up. And it's just a bunch of T flip-flops basically that are scattered in a one wide tillable, well, alternating design, I'd say. It's not really one wide tillable. And there we go. Alright, now this is all just some easy logic stuff. So I decided to make something a bit more complicated using this, just to show that this actually has applications. So this is a complete 8-bit adder. Now, it's probably, I don't want to say this is the most compact one ever made, because it probably isn't, but it's pretty darn compact. It's 10 by 10 by 1 per bit. So let's try it. So 3, we get 3 on the output. Then if I do 5, there we go, we get 8. So the adder works. It's a simple ripple carry adder. You can turn it off with this. The way it works is just like any ripple carry adder. So it has 2 XORs, 2 AND gates. Those link together using an OR gate to create the carry, and has obviously a carry in. I don't want to go into too much detail over how this logic works, but it's essentially just these logic gates over here put together inside a simple contraption. Alright, so this was just a showcase video. There will be a world download in the description with all of these logic gates. So hopefully people start using this type of logic a lot more. It's, in my opinion, completely superior to redstone. The only difference is it's a bit slower, but in survival, obviously that doesn't really matter. Alright, if you enjoyed, thanks for watching and have a nice day.